Hello all. Welcome to the lecture series Polymers in Applied Chemistry. The last two lecture series we discussed the first one, Introduction to Polymers, and how we can classify the polymers. And the second session we discussed the thermal properties of polymers. There are various thermal properties, and in this session we particularly take one thermal property. Particularly, we call it as TG. There is glass transition temperature, G for glass and T for transition temperature. And we discuss in detail. So, glass transition temperature. What is glass transition temperature? I can say an example. Suppose if you have if you are handling a very high temperature, I mean boiling water. Just we could take an example of boiling water. You would have been practiced in this, you would have been experienced in your home with the boiling water. If you just poured into a mug or bucket which you are handling in your restroom, the suddenly it quizzes without, it couldn't able to withstand so much heat, even the 100 degrees Celsius. So what happens that in certain temperature, suddenly it becomes soft. So the glass transition temperature TG means it's a temperature at which a polymer at which transit from a hard to a soft state. That is hard. In other words, we can state as a glassy state to a soft state. That is a rubbery or a loosey viscous state. Okay. Somewhat we say it's a melting to understand that. So it represents a second order phase transition, and it affects the flexibility of the material, and it affects the mechanical property of the material and processability of the polymers. So to understand TG is very important to classify the polymeric materials. And suppose if you want to use some certain particular polymer in an industry, that industrial machine can produce somewhat heat around 200 or 250 degrees Celsius. So how can we select the polymeric material? Instead of a metal, if we are using plastic, that even nowadays many bikes and cars, in many places the metals are replaced by the plastics. You know, so though how this property can be determined, how much temperature that can withstand is basically depends on this TG. So below the TG level, the polymer is rigid, brittle, glass-like state, no issues. And above the TG, that crosses the particular temperature, it becomes soft, flexible, and rubber state. So TG is critical for determining the application of the polymers, in which we have flexible polymer, rigid polymers, etc. When the TG is greater than the room temperature, it's a rigid polymer. When the TG is less than the room temperature, even at room temperature, the, the polymeric material become a glass or a rubbery state. So it's a elastomer, okay, flexible elastomer. So now we can discuss about factors affecting the TG. There are several factors affecting TG. One is the molecular structure of the polymer, then side group, any additional groups are present, and the molecular high molecular weight behaves different than the low molecular weight, and additional cross linking which has been found there, and high crystallinity and plasticized thermonuclear forces, etc. So first we discuss about molecular structure. So molecular structure we classify into two: backbone rigidity and flexible rigidity. The more rigid backbones will increase the TG, and the flexible chains will lower the TG. Example, the polystyrene and polyethylene for flexible chains. Then what about side groups? Side groups means branching in the polymeric structure. So a bulky branching or side groups, that is large side groups like benzene, polystyrene, can restrict the mobility of the polymers and which can increase the TG. If it is smaller one, then the mobility can be increased like hydrogen bonding. So there is a flexibility and reducing the TG value. And the high molecular weight MW. So when MW means the molecular weight, when it increases, uh, TG, because longer chain reduce mobility, smaller chain has more chance of mobility. So more molecular weight, more TG. Simple, directly proportional to each other. When the but when you when going on increasing molecular weight, it doesn't mean that TG is going on. So there is a limiting value. So above some particular critical molecular weight, there is no increase in TG. Up to a certain limit only they can increase. So what about the cross-linking? The cross-linking can be compared with the bulky or side groups. So cross-linking, that is increased cross-linking, restrict the chain movement, then TG rises. When this is less, TG is less. So high cross-linking, it becomes thermosetting plastic, thermosets. So high temperature, it's on high temperature, and there will be high TG like backlight, which you used in cooking utensils. So what about higher crystallinity? Crystallinity means it's opposite to the amorphous. Amorphous is nothing but without having any structure, and crystallinity is with structure, certain structure. So crystallinity reduces the amorphous region, therefore it increases the TG. The amorphous will decrease the TG, crystallinity will increase the TG. Semi-crystalline polymers will have some phase transitions. So plasticizers. Plasticizers are some additional material which is added to the polymers to increase its property. So addition of plasticizers reduces the molecular force between the polymeric chains and increase the chain molecule. When the force is reduced, the chains will undergo a movement. So thereby TG will reduce. So this addition of phthalates to PVC lowers the value of TG, and the PVC becomes more flexible with the addition of phthalates. See these examples which we producing here is to understand how it works. The intermolecular, again, when there's a strong intermolecular force, no movement, so increase in TG. The same thing. So the entire concept revolves around one thing. When there is a mobility of the chain movement, yes, the TG is less. When there is no mobility, the TG is more. So that's what the bulky chain says here, and cross-linking says here, and high crystallinity, intramolecular force, everything depends on that. Weak forces, low TG, like polyethylene. So what about copolymerization? We know that there are two types of polymerization discussed in a second series. One is addition and copolymerization. Addition, there is no elimination of molecules, but in copolymerization, there is an elimination of molecules by combining the two monomers. So the copolymers can increase or decrease the TG because of the monomeric composition. So when you go for addition polymerization, there is only one type of monomer, where in which TG generally depends upon the movement of chains, mobility of chains. But in copolymerization, the TG mainly depends upon the types of monomer which we are using here. See, styrene and butadiene copolymers have the TG between those of polystyrene and butadiene. That means we are taking two monomers and we combining into a polymer. The polymer TG value is between these two monomers. So in copolymerization, the TG value depends upon the what type of the monomers which we are using. These are some examples to understand the type of polymer and how much TG it withstands. Natural rubber, the TG value is 70 degrees. And polyvinyl chloride, it is 80. And polyethylene and LDP, low density polyethylene is 125. Nylon 6 is 50 degrees TG. That means above 50, it changes into a rubbery state. So hope you understand this TG values. and how the TG has been very important in applying those polymers in the industries. Thank you.